What's going on, everybody? Welcome back to another YouTube video showcasing more of the HackTheBox business CTF. In this video, we're going to hop into the forensics category. I'm super excited to be hanging out in here. There are a lot of really fun challenges in this one that I felt were, kind of pertinent to stuff that I tend to do, right? I showcase some cheeky analysis and deobfuscation things over on my YouTube channel here. So let's dive into the bad ransomware challenge. It was super fun, rated easy difficulty, but still kind of neat. You have a challenge information box here. It says a wave of phishing emails came in today that seems to be executing some kind of bad ransomware. The triage team said they created encrypted copies of all the files in your downloads folder, but forgot to delete the originals. Oops. Anyway, see if you can take a closer look and find the flag. So we have a downloadable part here that I'll go ahead and download, and we will open up a terminal and start to work. I'll move into the HackTheBox business CTF directory that I've created, the forensics directory, and the bad ransomware directory. I'll go ahead and make a new directory for us called YouTube because that's what we're working out of. And let's move that downloadable file in there. That was that bad ransomware in the forensics category. So now that that is in this current directory, I can go ahead and unzip it. As soon as I type in the proper file name, there we go. And we have this bad ransomware.docm. As you can tell, the .doc suffix in that file extension indicates, okay, this is going to end up being a Microsoft Word document. The M at the trailing end there means for macro enabled, or typically can use and will use macros. So this is a Microsoft Word 2007 and up Microsoft Word Office document. That M is interesting because that clues us in that there may very well be macros present. So I'll use a tool, OLEVBA, which I could use to kind of examine macros present in this document without even opening it up in Microsoft Word or even detonating that malware. So I'll pass in that bad ransomware.docm file, and we can see that it already found some kind of shady, spooky stuff. We can see that there is an auto exec call, or auto open really, that will run and execute code when the document is opened and you were to click on enable editing and enable content, stuff like that. It will run the shell command at some point where it can run an executable file or a system command. It might even call a DLL using Excel macros, might run code from that DLL, or try to obfuscate specific strings with characters. We could deobfuscate to try and deobfuscate things. I wonder if that will even work for us. I've never tried that. Can you run deop? Fingers crossed, maybe that got something here. Above this little synopsis and debrief down at the very, very bottom, we can see the full code that is kind of churned out here for us. And they use the CHRW as present. Let's try to grab this entire thing and work with it. I'll create a new file for us. We'll call this macro.vba, I suppose, since it will be a Visual Basic application that's ending up running here. And this private declare sub is actually going to end up loading in a function call from a specific Win32 API, like the library kernel32.dll. We're grabbing the sleep function. Now, interestingly enough, the sleep call is repeatedly called with sleep 0, which does nothing and isn't really all that useful for us. And some of you might notice, hey, this parallels really, really well to the very first malware analysis video, quote unquote, that I showcased on my channel, where we saw wscript.sleep and a lot of other strange, shady stuff like this and tangent functions. I think that became a good meme, and that, man, all these tangent functions and math going on. But all of these are being set to variables that are then never used. So first of all, let's start to kind of work with this. Let's take out this sleep, remove all these. I'll replace any line that starts with a new line character and remove it. I'm using regular expressions to denote the caret, meaning the start of a line. Remove all of those, and now we have a bunch of this stuff. We can see these variables that are declared and defined with dim here to denote, hey, creating a variable. But these variables, random number 219, 213, 216, etc., are then used with a math operation to set something with a tangent function. If you'll notice, I'll search for this variable name, and these are the only occurrences. So again, this is just making noise and running code for the sake of having code execute, calculating tangent functions, but it's not useful or really doing anything or used anywhere else in the code. So we can go ahead and nerf some of those out. I see a good many of them. And again, this parallels pretty well to that video that I had showcased previously in the past. I'll remove all these tangent function calls. We see this over and over again. We do see a for loop start to take shape in here as we're cutting through some of this. And some other variables that are called. Oh, yeah, that's already defined, but maybe indexing things out of this. Removing tangent function calls. Thankfully, there's not a lot in this. In that malware analysis video that I showcased, there were a ton, and that became a little bit of a painful mess here. But we can just kind of hand jam crank these out. Nice and easy, not too many. Eventually, we get down to that spooky shell call, where we are going to end up executing code and running commands here, but the rest of this is not necessary. So now we have a much shorter script and thing to work with here. Obviously, down at the very, very bottom, you can start to see PowerShell as a string starting to be built out, kind of in a reverse manner where we keep appending or prepending on to a variable that's being defined here. So that's cleaned up a bit, but we can see what this does and that it takes values from some shapes in the document. Now, if you're on Linux and you're working in LibreOffice, you can still kind of check out what that shape might be by opening it and checking what the alternative text is. We can do that super easy. In fact, I'll go ahead and do that now. Let me open up a file browser to access this. And I'm not all that scared. I'm in a virtual machine. It's not going to execute Visual Basic script here. So yeah, I know it contains macros. That's fine. That's fine. This is a nice, cheeky, classic phishing lure, right, for emails like this or Microsoft Office. It says, hey, please click on enable editing. Please click on enable content, so you could detonate and actually execute the malicious code here. If you were to right click on one of these images, and I'm going to assume these are the shapes because there's not a whole lot else going on in this document, I could actually right click and select properties, and that will bring up this big window in here. The image that's displayed, the options in here. The options tab actually displays the type and the name, of this object. And you can see this matches what we are already looking at in Sublime Text. That's the second alternative text here. So if we were to grab this alternative text only, we can see this big long payload, massive @ signs. So let's grab and replace for this specific object. And we also see this active shapes PLXCITRDD. That might be the other image very, very lower down at the bottom. You can see kind of the arrows and focus edges surrounding this shape here. Again, let's check the properties. This is, of course, that PLX object, and we can take that alternative text and slap it in here. With that, we can kind of put these together, because we know that's going to be one long string eventually. And what this code does, as we've seen previously, even in that other video, is that we would take this and take this @ sign, kind of triple @ signs here, and that's going to end up being used as a split operation, right? We have a ubound call, and am I actually indexing or splitting that? Did I nerf that out on accident? I might have. Let's grab all of this one last time and see if or I might just be missing it and not thinking. We should realistically have made that like an original.vba. Perfect. Did we have a split? We did, and I totally killed the thing. That was just before our for loop and ubound call. So let's get back in here. We could do this. There. We will split on this @ sign as a delimiter, and that's my bad for accidentally nerfing that out. That's the danger in doing that manual thing. But then we get ubound, which is the upper bound or the length of that whole list that's kind of generated as we split on this, the array that's generated with all of these. We grab that, and then we try to take an iterator, value E in this case, set to just the very, very start. Is that actually referenced anywhere else? Oh yeah, they define it as 0. Again, just before it, that I, again, nerfed out. I'm an idiot. E starts at 0 and then goes to that length. Now this is the variable that we've just split to act as a list or array, and we index it at that iterator. We then take the character CHR representation of that value, and we can start to concatenate them out into a new variable that will eventually be concatenated onto this PowerShell IAB, which really is going to run that as a base64 encoded command. That's what that TAC-E means, short for enc, short for encoded, and we could decode that base64 if we were to carve out all of this. And then it's going to be executed as a shell command. So with all of that said, let's go ahead and kind of recraft this or recreate it in Python. I'll make, again, a tinker.py script, and we can start a cheesy shebang line. We'll say that the data here can be a big, long string of all that. The Sublime Text Black is going to try and format this repeatedly, and it's going to have a hard time because that's so much data. So let's toggle that off. Let's go ahead and take that data and split it on that delimiter of 3 @. So we could say, I guess, like chunks. So for chunk in chunks, realistically, this is going to end up being a list comprehension. We could go ahead and print out the character representation of the chunk, right? And that takes an integer, so we want to cast that to an int because it is going to be a number like 74 or 65 or 69 as we work through each of these, removing that @ delimiter. There we go. Now we have a lot of data here. We could go ahead and make that a list comprehension, as we suggested, because eventually we want to join this all together as a string with new lines. We know that this is going to end up being prefixed onto, or appended, sorry, onto this PowerShell syntax, where it looks like the beginning of some base64 is present there. So let's go ahead and actually add that in. When we want to print all of this out, I totally failed. You need to add that, please. And this will act as our next payload. Realistically, we could save this as, I guess, like stage2.ps1 or something. You'll notice that there was an X at the very, very end of that output there. I've gone ahead and opted to remove that because the padding there is maybe not going to get in the need for that. Let's try and decode this, or base64 decode this, slapping that all into my terminal, and I can pipe that into base64 TAC-D. We'll redirect that into like stage 3 or whatever, even though it's not exactly a stage 3, depending on how you consider this stuff. But ooh, we've got some really, really good stuff here. Let's turn on word wrap so that we can see the whole chunk, and it's this goodness. This is eventually all going to be passed into an IEX, or invoke expression, right? Classic PowerShell, being able to run data sort of on the fly as it retrieves new information. It's essentially eval for PowerShell, right? So the thing about IEX is that it will execute this code, but we don't want it to do that. We also kind of would like to let PowerShell deobfuscate all of this mess on its own, because it's joining together some strings as it splits things by another delimiter and then taking the character integer representation, just as kind of we did in Python, but now doing that in PowerShell with another random delimiter. We could just sort of let PowerShell do that for us. I'm in Linux, but I do have PowerShell installed, that PowerShell core cross-platform one. So if I were to try and slap that all in fact, I'm actually going to probably save this as stage 3 and then just run that as a script so I don't paste in that entire chunk. That dies because something is not recognized as a name. Commandlet, that's fine. It's not supposed to be. It should be a string, please. Will that play nicely? Let's do a write host, maybe, or write. Now will you behave? No, still not. This has the right parentheses being mapped in here. But it didn't. Oh, no, that join should be closed. No, the join is necessary at the very, very end there. Everything else is included. I don't know why that split is being a pain. We could realistically kind of cave and just throw this into a regular Windows VM to go ahead and run that in actual PowerShell. Yeah, we could just fire one up. And I will pause the video recording as this machine gets started here. Okay, I have the Windows machine pulled up, and as much as I didn't want to originally go ahead and just paste this all in, I guess I'm apparently going to still end up doing that. So we'll let that crank through. It should be a relatively short chunk, though. Goodness. That is missing a closing parentheses. I don't know if I messed with some stuff. Oh, yeah. I kind of had that missing. I started to try and tinker with this to see if I could make sure that I was doing it wrong in... There we go. Okay, now that looks like kind of a mess, but is still relatively readable. Let's take this thing and bring it back into Sublime Text, where I have a lot of oddball spaces. I have to think that's because of like the UTF-16 thing, and how I maybe decoded this wasn't the best way to do it. Let's try to remove all spaces. I feel like that's a dangerous, horrible move, but I guess we'll find out. Let's set this to PowerShell. Okay, it looks like we have relatively readable code here. Let's call that stage 4, I suppose. And what this does is it tries to bring us into our downloads directory with maybe a variable here. Load file invoking a disgusting format string, but part of me wonders if that would still work a-okay. We could try and determine what that is actually churning out here. It tries to write that to null, but I don't think I want to. Will that fail? We need another parentheses. Are we missing a parentheses? Or do we have too many parentheses? What the heck is going on? Replace with parentheses. Yeah, we have way too many parentheses. Unexpected. Still, we have an unexpected token off of the web one. So let's close those up there. Do another? Do we only need one? This uses 2. But we realistically don't need 2 because I had copied that wrong. The new .web thing uses 2, and now we still have an extra at the very, very end, and an extra at the very, very end. Finally, my God, I'm truly sorry. This is what it would end up loading as the DLL. We can, I guess, leave that as a comment there. And then we use some, goodness gracious, removing all the spaces in this probably made this more hellish than it needed to be. But it looks like it's going to do a for each object is part of the get child item, just trying to make sense of the format string here. So we're looping through each object or file in that current directory. We get the full name .enct 012 with a format string. So we receive the object's name and we encrypt it, or even just change the extension at the very end. We take the stuff, being the get content representation of that file, the full name, and then we do a from base64 encode or invoke all of this. DRT as a variable, is that ever then used? No, it's invoked with the create encryptor. And then we take the memory stream with cryptography, again, making just slight mess out of the format strings being used here. And we could deobfuscate this more if we needed to, but I just kind of want to make sense of this. And then we write all bytes. So it's encrypting every single file that it finds in the downloads directory with a .enct file extension. And this key DRT looks to be an encryptor, but that's using some base64 in here. So maybe we could just determine what that value is. Let's run that in our PowerShell again. And we have these bytes here. What is the PowerShell convert bytes to, I'm not even typing in Google. Okay, PowerShell convert bytes to string, please. There's got to be a nice convenient thing to do this. Unicode get bytes from the string. They do it with ASCII as well. Let's try both. So to prefix this, we need this, which adds another parentheses. So we'll have to close that parentheses. And that's our flag. HackTheBox ransomware. Cute. Very nice. That was very slick. So I liked that challenge a lot because it felt like a little bit of an homage to kind of an original video that I had released. I remember I had seen HexDF or 0xDF had tweeted about, hey, this is a kind of a neat video. So I don't know if this challenge was his baby. I don't know if he made this one, but I enjoyed that. And props, thank you to you guys. Or it's just a straight up malware sample, right? And regular phishing for staging and obfuscating that code in Visual Basic script. So cool. Tangent function deobfuscation, more PowerShell work. Sorry for not fully deobfuscating this thing, but you could just crank this in. Obviously, you could do some simple ones like removing the concatenated stuff. The format strings you kind of have to parse through and work through, but that's that. I hope you enjoyed, everybody. I hope I didn't drag on too long for this sort of thing, but I enjoyed that challenge, and the forensics category for the CTF was a lot of fun. Hope to do more with it and bring stuff like that in the future. So, thanks so much for watching, everybody. If you enjoyed this video, please do those YouTube algorithm things. Please like the video. Please leave a comment. Please subscribe, etc. You know, it helps grow the channel. If you'd like to support me, there's a Patreon link and a PayPal link if you're interested in those things in the description. I am super duper thankful and really appreciate all your generous donations and support. Thanks so much, everybody. I love you. I'll see you in the next video.